For the last part of section 11.4 to 11.6, we're going to be looking at how we can write a series in sigma notation. And so sigma notation has that weird sum of symbol you might remember from when we did statistics, both in freshman year and again this year we saw this a few times. If we're looking at this sigma notation, there's that big E in the middle. That means the sum of. On the bottom of the sum of, we see an n equals a value. That is our starting point. Whatever that n equals value is going to be the number you begin with. The number at the top is telling you to go to that number. That will be the last value you go to. And the n here is going to tell you the sum of what to sum. So this is what it should look like, and if you look previously in the packet, you had already used sigma notation to go in the opposite direction we're going now. So for problem number 3, it's asking you to write a series for 7 plus 10 plus 13 plus 16 plus all the way to 64 in sigma notation. We're going to be using that same equation we had used previously. A sub n equals a sub 1 plus n minus 1 all times d. And so looking at this value, we can see this is definitely arithmetic. And we know that because 10 minus 7 is 3, 13 minus 10 is 3, 16 minus 13 is 3, and then we assume the rest of the pattern continues the same way. So once we look at that, we can see that we don't know a sub n to find our equation. But we do know a sub 1 is 7. That's our first value. We do not know n yet, but we do know d is going to be 3 based on the pattern. And we're going to go ahead and simplify to get that equation to put into our sigma notation. And our last step of simplifying, a sub n equals 3n plus 4. And so then we're going to write next to our sigma notation formula, 3n plus 4, that is our equation. So then the next step is to find out n so that we know where to begin and where to end. And so we're going to take the equation again, our a sub n equals a sub 1 plus n minus 1 times d. And we have 64 for our a sub n that's given to us in the problem equals our starting number 7 plus n minus 1 all times d, which is 3. And we're going to go ahead and simplify. 64 equals 7 plus 3n minus 3. Continue to simplify. 3n equals 60. Divide both sides by 3 and n equals 20. And so now at our sigma notation, we can put a 20 above because that's the number we go to. And we're going to start with a sub 1, so n equals 1. So that is the final formula for the first series. Let's look at the next one. The next one is going to be a neither. And so I just want you to be familiar with this. If you look at a pattern, and in that pattern, it really has no rhyme or reason to be arithmetic or geometric, it becomes a neither. So if we make 1, a sub 1, b1, a sub 2 is 8, a sub 3 is 27, a sub 4 is 64, and a sub 5 is 125. Looking at this, it seems like if we go 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, and 5 cubed is 125. And so if we look at those values, that can tell us that our pattern is to the third power. That does not fit into a ratio or the arithmetic. So this is going to be a neither. It's a finite, because that's the only one we're working with. And so our formula for sigma notation, we would draw our sum of symbol. Our last value would be 5, because we're going to stop at a sub 5, and we're going to begin at a sub 1. And the formula for the equation will be n cubed because it seems that all of those numbers fit. There's one more of these to do, and it is arithmetic, so please complete that in the packet.